Well, hello there. Good day, and welcome for today's lecture in water supply systems. As we all know, access to clean and reliable water is fundamental to human life and societal well-being. Today, we will delve into the intricate world of water supply systems, exploring the essential infrastructure that ensures a continuous and safe supply of water for our homes, businesses, and industries. We will examine the different components that make up these systems, from natural sources to engineered structures, and understand how they work together to deliver water from its source to our taps. We will also discuss the challenges facing modern water systems, including water scarcity, aging infrastructures, and the threat of contamination. By understanding these challenges, we can appreciate the importance of sustainable water management and innovative solutions to meet the growing global water demands. Let's begin our exploration of this vital aspect of our world. Well, in this specific slide, the image illustrates a typical water supply system, showcasing the stages involving in delivering clean water to customers. The journey begins at the source, where raw water is collected from natural sources like rivers, lakes, or groundwater. The raw water is then transported to a treatment facility, where it undergoes various processes to remove impurities and contaminants. Once treated, the water is stored in large reservoirs or tanks to ensure a continuous supply. Finally, the treated and stored water is distributed to homes, businesses, and industries through a network of pipes and infrastructure. Understanding the different stages of water supply system is essential for appreciating the complex processes involved in providing clean water. The image illustrates the importance of maintaining the upgrading water infrastructure to ensure the reliable and safe water supply for communities. The water supply system is a vital component of a modern society, ensuring access to clean water for various purposes. The certain image depicts a typical water supply system, showcasing how water travels from its source to consumers. It begins with the raw water drawn from a water source like a well, then stored and treated to remove impurities, pumping station, and move the treated water to storage tank, which provides pressure for distribution. The water flows through main lines, branching into sub-main lines, and then individual lines to home and businesses. Public water taps, known as stand posts, are also connected in the system. This complex network ensures a continuous supply of clean water, with each stage playing a vital role in maintaining quality and pressure. The system is essential for modern society, providing access to clean water for various purposes.
So in water supply system, we need to consider the sources of water that we are going to extract. No? So in this part, we are tackling two major components of sources of water. So which is the groundwater and surface water. So the groundwater is water located beneath the earth's surface, stored in soil or rock formations. Surface water, on the other hand, can be found in natural water bodies on the Earth's surface, such as rivers, lakes, and streams. So, in this part, we are discuss more detailed in these two components. No, so let's start with the groundwater. The first types of groundwater is what we call open wells. So, these shallow wells that reach the upper layers of the groundwater, they are manually dug and are common in rural areas. So these open wells, also known as in our terms, is tabay, no? That we are extracting water. Another type is what we call hand pump wells. So these wells allows water to be extracted through hand pumps, typically used for small scale water needs. So as you can see in the figure, no, we are familiar with this since um, tanan ta kay murag naman siguro inaani sa atong panimalay. So natay bomba, no? It just hand pump wells that can extract water that we can use in our domestic. The next type of groundwater is tube wells. These are deeper wells equipped with pumps to access water from greater depths often used in agricultural and industrial applications. So, as you can see, nasa pipes, drilled pipes, and with a combination of pipes, no, for agricultural and industrial application. But and the last types of groundwater is the bore wells. So similar to tube wells, but typically drilled to even greater depths. Bore wells are ideal for accessing groundwater in areas with lower water tables. So let's proceed with the surface water. No, the second type of surface water is the ponds and lakes. So stationary bodies of water that act as a reservoir for water storage and are used for recreational, domestic, and sometimes agricultural purposes. So, as you can see in the figure, no, the example of ponds. The first types of surface water is what we call rivers and streams, or it is the flowing bodies of water that can be used for irrigation, drinking, and industrial purposes. And lastly, the types of surface water is what we call springs. So, natural water outlets where groundwater flows to the surface, often providing a reliable source of fresh water. So, this fresh water is very, no, very potable since it is a natural. Okay. I think that's all for the surface water. In water supply system, it is important to consider the source of water that we are able to extract. So, thus, choosing a water source depends on balancing ease of access and infrastructure cost. Local sources are ideal for being nearby and cost effective, while distant sources provide a steady supply when local options are not enough. Though they require more extensive infrastructure, it is really important to determine the accessible water source in our water supply system. And that's all. Thank
For the next part of the report, let's tackle treatment of water. So just a quick overview on what is a treatment of water. So the treatment of water is essential for producing safe, potable drinking water. It highlights the primary reasons for water treatment, describes key processes in treatment of various water sources, and examines specialized treatment techniques. So there are two reasons for water treatment. First is it is for health protection, and second for aesthetic qualities. So as you can see in this picture, it shows the fundamental water treatment processes. So let's talk about those processes. So the first one is oxidation. So oxidation is a chemical process that converts contaminants into a state that can be filtered or removed. It is used to remove inorganic substances such as iron, manganese, and arsenic, and it eliminates taste and odor-causing compounds. So common oxidants includes chlorine, ozone, and potassium permanganate. Second is coagulation and flocculation. So coagulation destabilize or suspends particles by introducing coagulants such as aluminums and ferric salts. So it neutralizes particle charges, allowing them to aggregate. And on the other hand, flocculation involves gently stirring the coagulated water, increasing its collision between particles to form a larger aggregate or a floc. So the effectiveness of these processes depends on water properties, pH, and chemical doses. So third is the sedimentation. So sedimentation removes larger particles or katong flux from water by gravity. So clarifiers and sludge blankets are used to enhance sedimentation's efficiency, so which separates solid particles from treated water. The settled material or sludge is removed by hand or by another process. So next is the filtration. So filtration physically separates suspended particles by passing water through porous media, including sand and member filters. So types of filtration processes includes granular filtration, membrane filtration, activated carbon filtration, and last is the disinfection. So disinfection inactivates or kills pathogens in drinking water. So method includes chlorination. So chlorination is widely used for its effectiveness and cost efficiency. Second is chloramines. So chloramines provide a stable, long-lasting residual but are less potent than chlorine. Third is the ultraviolet or UV light. It damages the DNA of microorganisms, preventing them to reproduce. And last is the ozone. So an ozone is a powerful disinfectant but challenging to maintain as a residual, and making it is is primarily a disinfectant. So that's all for the water treatment processes or for the treatment of water.
Now, we're going to talk about the water storage facilities. Here in our report, I'm going to discuss about the three types of water storage facilities. First is the Elevated Surface Reservoir or ESR. So, ESR is a high-level water storage tank typically built at a height of over 15 meters to facilitate water distribution through gravity. This design is especially useful in areas with uneven terrain or where their water needs to be supplied over long distance, as the height allows water to flow naturally without requiring continuous pumping. In some cases, pumps are also used in conjunction with ESR to boost water pressure if necessary. Second is the Ground Service Reservoir or GSR. So GSR is a storage tank situated at the ground level on a low platform or generally not higher than 3 meters. In its storage capacity is determined based on factors such as local water demand, availability of electricity for pumping, and hours for supply. GSRs are usually designed to hold half a day to 4 days water requirement, providing a steady supply based on the pumping schedule or daily demand. And lastly is the sumps, or also known as underground water tanks. So sumps are extra storage tanks at the community or cluster level. These are underground structure, often circular with dome covering, that acts as intermediate storage. They are not used for direct water distribution but rather storage for temporarily before it pumped to the ESR or GSR. The capacity of sump is typically larger than ASR or GSR, enough to hold water for one or half two times of their capacity, or enough for 2 to 5 days. This ensures that water remains available during supply disruptions. Together, ASR, GSR, and SUMPS works to provide reliable water distribution and storage across different landscape and community needs.
Types of water supply. So there are two types of water supply, the continuous and the intermittent water supply. So first, the continuous water supply system. So it provides a consistent 24-hour supply of water to consumers. So this system is ideal as it allows access to water at any time, maintains better water quality, and requires minimal storage at the household level. So there are advantages of continuous water supply. It is reliable access since consumers have 24-hour access to water, which is essential for daily activities, hygiene, and sanitation. And also, it improved water quality since water remains pressurized in the pipes. There's a reduced risk of contamination through leaks or backflow. So this can help maintain water quality and safety. And also there are disadvantages of continuous water supply. So it is higher operational cost and increased infrastructure demand. Since continuous supply requires better maintained infrastructure and pipes, leaks and wastage can become costly if the network is old or poorly maintained. Next is the intermittent water supply system. It provides water at specific hours or days, so it with breaks in supply. So this type of system is common in areas with limited water resources or infrastructure, leading households to store water when it's available. So intermittent systems can sometimes increase the risk of water contamination as breaks in supply can lead to backflow issues. So there are advantages. It reduces operational costs since water is supplied only during certain hours. less energy and infrastructure maintenance are required, potentially lowering costs for water provides. It also the advantage is also adaptability for resource limited areas and flexibility during scarcity. The disadvantages are inconsistent access and increased contamination risk. So when supply stops, pressure in the pipes drops, allowing contaminants to enter the system through leaks or backflow when water flows again. So this can compromise water quality. So water supply systems are usually designed and built to water available under continuous pressure 24 hours a day in order to fully meet demand. In case of water shortage, the supply can be adapted to an intermittent water supply, which serves different users at different times.
For water demand and supply management, so first is for understanding water demand. So water demand depends on the things like population growth and city expansion with different needs for homes, farms, and industries. So predicting future demand helps us plan water system and also to avoid shortages. So second is water for water supply sources. So main water sources are rivers, lakes, and underground reserves. So but we also use desalination, rain collection, and recycling. So these alternative sources are important for areas with limited nga water. So third is for supply management strategies. So building and fixing water infrastructure like pipes and treatment plants helps keep water flowing and reduce waste. So reusing treated water for irrigation or industry saves fresh water for drinking and household use. Fourth is for demand management techniques, so setting water prices, educating the public, and using water saving devices can reduce water use. So these steps encourage people to conserve and avoid wasting water. So and fifth is for monitoring and evaluation. So smart meters and tracking tools show how water is used, helping managers spot and fix inefficiencies. So measuring and water loss and usage patterns helps improve the system over time.
Challenges in water supply system. So first challenge is the population growth. So kabalo man tanong nga, as population grow, so pag mudaghan ang population, daghan pod ang demand. So it can overwhelm existing infrastructure and lead to shortage, especially in urban areas. So that's why population growth is one of the challenges. The next is the climate change. So change in weather patterns like reduced rainfall or increased droughts affects the natural replenishment of water sources, making supply unpredictable. So, di ba, some of our source of water is in the groundwater table. Then the groundwater table must be kanang dapat makuan gid pod siya, kanang ma-recharge siya by sa mga ulan, o pag naay mga change in patterns or mas daghan ang dry season compare sa kanang rainy season, so dili ma-recharge ang atong groundwater table, which is isa pod ang groundwater table sa atong mga ginakuhaan sa ato ang supply sa atong tubig. Then for the next is the aging infrastructure. So katong mga karaan nga infrastructure nato sa atong water supply system like pipes and facilities, so na-deteriorate na sila over time. So it can cause leaks and frequent breakdowns and inefficiency, which increase operational cost and reduce supply reliability. Then next is the pollution. So katong mga contamination sa atong tubig from industrial waste or agricultural runoff and makes water unsafe and costly in treatment and process to meet the health standards. So pollution isa siya sa challenges sa pagkuan sa water supply system. It is because na mga contamination sa water, and because of that need nato siya i-treat. So by doing so, it can cost more money. So pag costly siya, makakuan po siya sa kanang sa ato so kay costly man siya. Then next is the funding. So adequate funding is often lacking for essential upgrades and maintenance, so leading to deferred improvements and greater long-term cost and issues. So katong lack of funding from the government for the upgrades and maintenance for our supply system, isa po siya sa challenge kay pag dili na to na siya ma-well maintained, so mas dali ang iyahang kuan kanang life expectancy ato nga mga parts sa water supply system. The next is the water loss. So katong mga leakage and inefficient distribution system results in significant water loss, which means less water reaches to the end users and raises operational costs due to wasted resources. So katong mga na-leak nga mga pipes, so isa po to siya sa challenges kay katong mga nasayang ang tubig and then wala siya nakaabot sa katong mga end user niya na ato. So that's all for the challenges in water system.
I am Sarah Izoleta, and for my part in the report, I will be discussing the basic planning and estimation of water supply. First step is to calculate the water demand for domestic, institutional, commercial, and other water supply use. For example, a town might calculate that each household needs 150 liters of water per day. With 1,000 households, the total daily water demand would be 150,000 liters. Second is to assess the water availability for a water supply system through water availability and usage from the surface, ground source, as well as rainwater harvesting system. For example, in an area with a nearby river, planners may assess the flow rate of the river and its seasonal variations to estimate how much water can be sourced sustainably throughout the year. Third step is to assess the domestic water gap, which is the difference between the yearly water demand and the yearly water availability. For example, if a community's demand is 200,000 liters per day, but only 150,000 liters is available, there is a gap of 50,000 liter that needs to be filled. Last step on basic planning and estimation of water supply is the estimation of components using the water supply by calculating the existing and gap number of household taps, stand posts, and hand pumps, ESR or elevated service reservoir, and GSR or ground service reservoir or sump treatment unit, pipelines, and others. For a town expanding by 500 new households, planners would estimate the additional number of taps, meters, and connections needed, as well as potentially larger pipelines or additional treatment units to handle the increased demand.
Good day everyone, my name is Kian Repulson G. Yusun and I'm about to report for the topic about rainwater harvesting on rooftops. So what is rainwater harvesting on rooftops? Rooftop rainwater harvesting system is being used for most of the places around the world who has if not lacked, but inadequate amount of water resources in a certain area, which they cannot consume enough water for their daily basic needs. So through this rainwater harvesting on rooftops, they can eventually have an alternate source of water sources which they can consume from their basic uses aside from drinking, other from washing clothes and other domestic uses. And rainwater harvesting can be effective on most places, particularly in rural areas who doesn't have enough access to the modern and technological and more advanced water systems which can be utilized through government and institutional approaches. Rainwater harvesting system on rooftops can be as easy as it seems if we know how to manage the materials which is being composed on how we construct rainwater harvesting materials even in our homes. Rooftop rainwater harvesting system comprises of basic components, which is composed of filters, pipes, and catch basins, which we can store our water from, which is being collected from the rainwater. Uh, Storage facilities, which is common, and most importantly is the filtration system, because if we cannot consider this, most of the times if we manage to neglect the drainage path of the water which is being transported, there are tendencies uh, that we can see sedimentation which being occurred, or most instances that the pipes that being used had been clogged due to these circumstances. And that's it for my presentation, and it's that is for my presentation, and thank you for listening.
Well, that's will be all for our lecture discussion, and thank you for listening. Bye.